Welcome to Focus Academic Solution online class. Today I'll be teaching on special relativity. So I'll base on my topic on length contraction. Okay, I'll be using these on frame of reference. For an example, is still coordinate, Cartesian coordinate. So the frame of reference, for an example, so I will label this as my x. This is my x. Right here is my s prime. Here is my s prime. So I have here x, y, and here is z. So I'll put what prime on it. S1 and z prime. Likewise, I'm having x, y, and z prime. So from here to here is length L, and from here to here I can label it as a distance A and B, distance A and B. Same thing here. This is my length. This is my length. So I'm having again distance A and B from here. Distance A and B. Alright. That is, I can say, now let me label this figure as figure 2, figure B. So the observer in frame of reference of figure A, the observer in frame of reference of figure A will be, so I will have A open bracket x, y, z, t, because we will be dealing with time. So these are observer. Likewise, you will be having, okay, I will have x1, y1, z1, and t1. Likewise, B, I will have here s2, y2, z2, and t. So this is the observer in the frame of reference x. Yeah, figure A, that's x. So I have again the observer in frame of reference of figure 2, figure B. So that's s prime. So A in s prime will give me what? S prime. The observer in the frame of reference of figure B, which is s prime, will be giving us s prime 1, comma, y prime 1, comma, z prime 1, comma, t. While the B I will have s prime 1, comma, y prime 2, and so on like that, and t. Alright, so I've gotten the Cartesian for what? Both figure A and B, that is the observer in their frame of reference, are this. So next thing is that now the length from here, from L to L1, can give me the change in length. That's s2 minus x1. So I can put it right here by saying that here is s1 and here is s2. So here is x1, here is s2. So I can say that what length for L will be equal to s2 minus x1. Let me call this equation 1. Likewise, L prime will give me s2 prime minus x1 prime. I call this equation 2. So using using Lorentz transformation. Lorentz transformation. Lorentz transformation, which says s prime equal to x minus vt all over root of 1 minus v square over c. Okay, here is Lorentz transformation. So we can solve using Lorentz transformation by saying that s prime is equal to x1 minus vt all over root 1 minus v square over c square minus s2 minus vt all over root 1 minus v square all over c square. That is, we can find the LCM. Let me call this 2 and here is 1. So looking for the LCM. The LCM of this will give me root 1 minus v square all over c square, which is s prime equal to. Alright, good. So you can proceed by saying that. So I will have what? S2 minus vt minus open bracket x1 minus vt. So we have what? X prime equal to s2 minus x vt x1 plus vt all over root of 1 minus v square all over c square. You can see this. So vt cancel vt. So we have that is s prime will be equal to l prime. So we have here equal to l prime to give us x2 minus x1 all over root of 1 minus v square all over c square. So we have this, that is L is equal to s2 minus x1. So we have L prime to be equal to L all over root 1 minus v square all over c square, which is equal to L prime equal to L prime. So L equal to L prime root of 1 minus v square all over c square. That is length contraction. Length contraction is equal to L prime root 1 minus v square all over c square. Right here is our length contraction. I would like all viewers to subscribe to my YouTube channel for more videos. Thanks for listening. Here is Focused Academic Solution. I really appreciate. Thanks for listening.